In this video, we're going to focus on the related doubles, the times 2, 4, and 8, and those relationships between them. Now, our young students hopefully learn their doubles within the addition math facts when they're young. And if the students are not able to learn those, well, then I have them use their fingers with me. Now, we can use our fingers in ways that are not the inefficient ways of counting everything or even skip counting in the world of multiplication. For example, I can hold up this number of fingers. So I'd have my students show me this number of fingers for our 7. But then with our fingers up, I would say, well, how many are these 2 5s? Their 5 and my 5 is 10. And their 2 and my 2 is 4. And 10 and 4 is 14. So we're using our fingers, but not counting on 7 from 7, but to look at the groups within those addends and do the 5s and the amount that's left over. And so our students are working independently and need to know, let's say an 8 plus 8, they can use their fingers, but they can think, okay, 2 5s, that's 10, and 2 3s is 6, and 10 and 6 is a 16. Very different thinking than counting it on. So once our students have learned the double facts, we can then learn about how a times 4 is double a double. When I have 4 groups, that's double my doubles. And again, once we learn about that relationship, we're able to multiply anything by a 4. And then for our times 8s, similarly, we can think about our times 8s as being double our times 4s. So if I spent some time mastering my times 4 math facts, I can then be figuring out my times 8s. Now, I may not be very speedy at first, but as I practice this, I know it's a way that I can learn to find out that times 8 when I don't know it. If I haven't learned that and put that into my long-term memory yet, I can derive it. One way I can think about an 8 is to double my 4s. Now, please know this is not saying that we have to do a double of a 4 when I see an 8. If I've built my flexibility, I can think about an 8 as being 5 groups and 3 groups. Maybe I know those two partial products myself. Or if I don't know the times 4, I can think, well, what's double? And then double it again, and then double it again to get to my 8s. So again, we're trying to use any facts that we know to derive the ones that we don't know. Again, for a times 8, maybe I know the math fact of times 7 of the other factor. I can do one more group to get to the 8. So these relationships are really powerful to explore, but they're not a dictate. We're not dictating to our students they must use a certain one over another one. Let's begin by focusing on the relationship of 2 doubling to 4 using this manipulative of these colored tiles. So first of all, we have 2 times 3, which could be interpreted one way as 2 groups of 3. So I can think about this 3 and then another 3, and that would, of course, get me a total of 6. Now, when I'm thinking about 4 times 3, I've got double the amount. Let's take a look and see how that looks. So here I have that 2 groups of 3. And if I just do it again, now I have my 4 groups of 3. But you can see how it's double of what the 2 by 3 was. So if I do 4 times 3, I can think, well, double the 3 would be 6. Doubling the 6, I know I can get to my 12. So 4 times 3 must be 12. Let's take a look at that using a rekenrek. So here we have an example of determining 8 times 7. So if a student does not know that from memory, so they can't retrieve it from their memory, how could they derive it? Now, the 8 groups of 7 is double the 4 groups of 7. Let's take a look at that. Here we have 8 rows of 7. I can tell that it's 8 because I know it's color coding at the 5. And I can supertize this 5 and supertize this 3. Okay, so then know that that's an 8 groups in all. And there are 7 in each row because 7 is 2 more than 5. This all feeds into all the elements of number sense. They want students to develop their understanding of these quantities. And so I have 8 groups of 7. If I don't know how many that is in all, we want students to use this multiplicative reasoning and that relationship of about 4 being half of the 8 groups. So if I were to separate these 2 sections into 2 groups of 4. So hopefully our students will know that the 4 times 7 is 28, in which case these amount of beads would be 28. And then these amount of beads are a matching 28, right? It's a related doubles fact. So we have a 28 and a 28. That's where we can begin discussing how do we double The 28s, do we want to do two 20s and add to that two 8s? Do I want to think about, well, 30 plus 30 would be 60, but I'm missing 2 in this 28 and 2 in this 28. So I can come back 4, right, to get to my 56. However you want to help the students think additively to the total of that 56 in all, right? That 8 times 7 is 56. But I love this rekenrek for being able to see these relationships. And again, they don't know that 4 times 7 is 28. They could then reason their way that 2 of these 7s is 14, and the 4 groups is another 14 to make that total of 28. Another favorite manipulative of mine is Cuisenaire rods. Students are seeing these numbers existing as a group. So let's figure out what 8 times 6 is. But let's start and see this relationship here. So 2 6s. So I can drag out a 6 rod and a 6 rod, right? So as we use Cuisenaire rods with whole numbers, that rod is worth 6 of these 1 units. And so that's worth 6 units in all. So 2 6s. When students begin drawing these with like arrays and they have their X's, I have watched the students then count the X's. So we want to help move our students to be more efficiently in thinking about these as equal groups. So I love how these Cuisenaire rods can do that for us. Now, I don't normally use the labels of the numbers on these, but I want our students to think about relationships. If I know the benchmark of the 5 units is yellow, I can reason that 6 is 1 more than that, making the students do the thinking. So I don't typically use these with the numbers on them, but in case you aren't familiar with the length of these rods, I wanted to show that for you. So 2 6s I can then think about is going to be my 12. Now, when I'm doing the 4 groups of 6, right, I can see how I have these 2 groups of 6, and now I have 4 groups of 6, but you can see visually how the 4 groups of 6 is double the 2 groups of 6. And then similarly, our 8 groups is double of the 4, right? So powerful as a relationship that can help our students be able to visualize these related doubles facts. And again, not just help them with their basic facts, but to unlock multiplying anything by 2, 4, and 8.